So now we're going to put together finding definite integrals. So we looked at finding equations, so anti-differentiating. Then we looked at the graphs a little bit the other day and going from a certain value to another value, finding the area of that. So now we're going to work a little bit more on that and try to figure out what that numerical value is between the lower limit and the upper limit. So the fundamental theorem of calculus says we're going to integrate from a to b of f of x with respect to x. That's equivalent to finding capital F of b and subtracting capital F of a. Again, it's that integral, so I just kind of wrote it out here, from x equals a to x equals b of f of x with respect to x. So that's what this stands for. So we're looking at a definite integral. It's not going to keep going forever. So we're restricting what x values we can look at. So we're going to have a lower and upper limit for that integration. And because of that, we're going to find that area, which is just a numerical value. It could be positive, it could be negative. Additionally, another notation piece that you're going to see, f of b minus f of a is exactly the same thing as capital F of x. And then I just drew this line last week from b to a, or last time. It's equivalent to both of them there. It doesn't matter which way it goes. So those representations mean the same thing. So we are going to do this by hand, and then I'm also going to show you how to do it in your calculator too. Your calculator can find these for you. So being able to do this without a calculator, they're pretty straightforward to do without your calculator. Just have to make sure that we know how to integrate. So we started with integration earlier. So ignoring all this part here, we learned how to integrate this. So again, going backwards. So undoing that derivative. So same thing's going to work. Sometimes we can't do it. And that's where we're going to use our calculator. And then we're going to learn some different techniques for integration. So to begin with, let's start by anti-differentiating x squared plus 2. So x squared plus 2 is x cubed over 3 plus 2x. And then that goes from 1 to 3. So we're going to find the area of that. So again, it's going to be a numerical value. So as we stated here, we find f of b and we subtract f of a. So therefore, I have to, so this is capital F of x. So now I have to do f of 3, and then I'm going to subtract f of 1. So therefore, when I substitute 3 in, I get 27 over 3 plus 6, and then we're going to subtract f of 1, which is 1/3, plus 1. So 1 and 1/3, or 4/3. So when I go through, I get, so 9 plus 6 is 15, minus, oh, that's a plus 2, sorry. Minus 2 and 1/3, which ends up giving me 12 and 2/3. So again, we end up with a number because we are finding the area with restrictions instead of just finding the antiderivative, instead of just finding the equation. Okay, next one. So we've got two different problems here. We're going through giving you guys a trig function, and then the second one has another one that's a little bit more difficult, I guess, if you want to think about it that way. So finding the integral from x equals 0 to pi over 3 of the sine of x with respect to x. We have to undo the sine of x, so undoing the sine of x, so capital F of x, is negative cosine of x, and then that goes from pi over, well, it's from 0 to pi over 3. Okay. So now I'm going to calculate f of pi over 3, and I'm going to subtract f of 0. So therefore, plugging in pi over 3, cosine, pi over 3, cosine for that is a half, but then it's the opposite of it, so it's negative a half. And then at 0, cosine at 0 is at 1, but it's the opposite of that, so it's minus a negative 1, so in other words, plus 1, which simplifies to a half. So therefore, this equals a half. It equals a value. Okay, then this one, this is one that often gets messed up when we integrate it, and that's the x in the bottom. So when it's 1 over x, remember the antiderivative of 1 over x is the natural log of x. So 2x becomes 2x squared over 2 plus 3 times the natural log of x, because again, this is like 3 times 1 over x. And we integrate, 3 is still 3, and then 1 over x is the natural log of x. And then that whole thing, and this is why a lot of times you see these brackets, because it's the whole thing, that goes from 1 to 4. So that simplifies, that's just x squared. So therefore, we're going to do f of 4. So 16 plus 3 times the natural log of 4, minus, plugging in 1, that's 1 plus 3 times the natural log of 1. And continuing through, we end up getting 16 plus 3 times the natural log of 4 minus 1. And then this, the natural log of 1 is 0, so 3 times 0 is 0. So then it's just minus 1, which gives me 15 plus 3 times the natural log of 4. And that's a number, because the natural log of 4 is just some numerical value, but that's my exact value. Okay, the next one. So, taking a look at this, anti-differentiating x times e to the x. We cannot undo a product. Okay, so because of that situation, we're going to learn in the next lesson, there's some special cases that we can do, but other times we're kind of stuck. So what we can do now is we can use our calculator. So in order to use our calculator, grab those out. And we are going to substitute in the equation. So x times e to the x, I put it into y1. And so now when I graph this, we get this graph. And what we're doing is we are finding the area under the curve. And we are finding the area under the curve between 2 and 5. So to do that, you're going to go second, trace. You're going to go to your calculate key. And then way down here on the bottom is the integral. So we're going to type in 7. We already have our function. Now it asks for the lower limit. So what's the lower limit? Well, that's just 2. Enter. And then it says, what's the highest number? Well, that's 5, or the upper limit. Now, my graph keeps going quite high vertically, but this is what's telling you the area is underneath that curve. And it tells you on the bottom right here. It's 586.264. So, back to our lesson. So this calculator is 586.264, and then units squared, because it's area. Okay, so that's how we can use our calculator. And what you can do is you can go back to the last problem, and you can plug this into your calculator, and you can do the exact same thing. Okay, and you'll be able to do that for B as well. So you'll be able to figure out what they are without your calculator, which is what we're going to typically test you on, and I'm going to check your work for. However, we can also do it with our calculator, making sure that you know how to do that. Okay, so again, these are just some integration rules, so take a moment to look at those. Just being as comfortable as possible with these. Okay, so 2 more examples for you. So here's a very traditional problem. Find the exact value from 1 to e. You all should know that e is bigger than 1. E is about 2.7. So now, anti-differentiating this, we get natural log of x plus 4x from 1 to e. So plugging in my information gives you the natural log of e plus 4e minus the natural log of 1, and then technically it's minus, because it's subtracting the whole thing, 4 times 1. So therefore, simplifying, natural log of e, remember natural log is a base e, so log base e of e is 1, plus 4e. Natural log of 1 we already just did was 0, because e to what power is 1? That's 0. So then that gives me for a final answer, negative 3 plus 4e. Again, that is a numerical value because we have limits. We have a start and we have an end. Okay, last one. I changed the integral. I am going from 4 to 9. I can't remember if I changed it on the note sheet before I sent it out. But I did that because of the numbers that we end up getting in the problem. Okay, so we're going from 4 to 9 of this function. Hopefully you realize you can't do it as it sits. I can't undo that division. Okay, I'd have to expand out that square. So you are going to have to actually simplify this whole thing. So you are going to have to expand out the square. You're then going to have to send through the square root of x. So therefore, just showing some work. It takes time, and you've got to be super careful. So x minus 3 squared, x minus 3 times x minus 3 is x squared minus 6x plus 9. And that's all being divided by x to the 1/2 power dx. Okay, so since everything is being divided by x to the 1/2 power, I can simplify this into non-fractional situation. So I'm dividing this by x to the 1/2, which gives me x to the 3/2, because 2 minus 1/2 is 1 1/2, or 3/2. And then minus 6 to the 1/2, because 1 minus 1/2, plus 9x to the negative 1/2 dx, and we still have that integral from 4 to 9. So now we have to anti-differentiate this. So kind of ugly with the fractions, but totally doable. Add 1, so x goes to the 5/2, which means you have to multiply by 2/5. Minus, oh, I lost my x on 6. 6x to the 1/2. So minus 6x to the 3/2, which means we have to multiply by 2/3. And then plus 9x to the 1/2, which means we have to multiply this by 2. And that's going from 4 to 9. I'll just slightly simplify this here. Let's see, that's a time sign there. So this is 2x to the 5/2 over 5 minus 12. So that's 4x to the 3/2 plus 18x to the 1/2 from 4 to 9. And then, last step, I've got to just plug in my values, plug in my 9, plug in my 4. The other reason I changed them is it makes much nicer values because these are perfect squares. So, starting with my 9, so right now what we're doing is we're calculating f of 9 and we're subtracting f of 4. So starting with 9, that's 2/5 times 9 to the 5/2 power minus 4 times 9 to the 3/2 power plus 18 times 9 to the 1/2 power. And then we're going to subtract out 2/5 times 4 to the 5/2, and then this becomes a plus because I'm distributing that minus sign through. So 4 times 4 to the 3/2 minus 18 times the 3/2 to the 1/2 power. So again, I just sent through that subtraction sign. And then simplifying each piece as we go. Now it's just the math behind it that takes a little bit longer. It's not the calculus. So 2/5 times 3 to the 5th minus 4 times 3 cubed plus 18 times 3 minus 2/5 times 2 to the 5th plus 4 times 2 to the 3rd minus 18. Why did I put 3/2 there? That should be a 4 here. Sorry about that. Let me just fix that. That should be 4 to the 1/2, right? Just double checking my work. Yep. And that's minus 18 times 2. And then when all is said and done, because I'm totally using my calculator on this, I'm going to end up getting 26.4 is my answer. Okay, and if I wanted to, I can put this into my calculator and we can graph it as well. So we have parenthesis x minus 3 squared divided by the square root of x. And we are going from 4 to 9. So second, calculate. Number 7, 4, 9. So that is my area under the curve. Okay, so now you know how to evaluate definite integrals where they have that bound, and we can look at it graphically, and then we can also do it algebraically.